Hello and welcome back to Calculus 1, section 3.8, Implicit Differentiation. So the question here is, can we take derivative of anything, of any type of a curve? Circle, not a function, but it's a curve, and definitely has tangent lines. So that's one of the indicators that derivative can be taken, even though if we do not have a function. We know that, say, circle, right, is not a function because it fails vertical line test. Its equation, x squared plus y squared equals to, let's say, 9, does not fit the definition to write y equal everything else, and therefore our good old methods to find the derivative don't work. They don't work. So this is vertical line test, right? But we know that at every point of the circle we can draw tangent lines, and the slope of the tangent line comes from the derivative. So there has to be a way to find this derivative. Well, we can actually find this derivative by use of the chain rule, which is great. Before we do any of that work, we have to first think about explicit versus implicit functions and forms, right? Expressions, and then we can dive in and actually do some of those derivatives. So we start by first writing, let's say, y equals 3x squared plus 6x minus a to the x. All right. This is something that will be called explicit form, because you have y equals everything else. This is also a function at the same time. It's a function. But then you have those expressions that are not functions, and they still give us curves in space, like the one above. But I can come up with another one. So say I have x sine y is equal to y squared minus 3. Now this would be implicit. Well, it will be implicit once we move everything to the, let's say, right-hand side equal to 0. So I can write x sine y minus y squared plus 3 equal to 0. And this would be implicit form. There is no way to isolate y from here and make everything y equals as a function of x, because the curve that you're seeing is not a function. Now you can see that you can't do this because one y is buried under sine. And if you use the inverse sign, to free up the y that it's within sine, the inverse sign will bury the y squared. Plus the y squared, you can't do much about that either, because if you take square root, you will have plus minus, which immediately bifurcates your answer. So we have explicit forms, and that's for functions, and then we have implicit forms for relations that are not functions. And now that we have the implicit form, we can start taking derivatives. Now, before we do any of that stuff, I just want to make sure that we all understand that taking the derivative is, we take it term-wise. We know that from 3.2. So I can, or 3.3, whatever the rules were. I can write y equals x squared plus 3x minus 6, let's say. And then I can write as a notation, I can put the derivative like this on the outside. And I can say I want to take the derivative of this particular function this way. All right, so y and x are not the same variable. Y is a function of x, which means that when I take the derivative of y, I have to follow the chain rule. So derivative of y is 1, and then times the chain rule is dy dx. On the other side, I have the derivative of x squared is 2x. And you know what? I'm going to follow with the chain rule we never wrote before. Dx over dx. Plus 3, another dx over dx. And then minus 0, right, for the derivative of 6. Now, this dx was supposed to be present for us since day 1. But we didn't put it there. So look what happened here. You have that your dy dx is simply equal, these guys are going to cancel, 2x plus 3. Now, that is exactly what you would say if you were just to take the derivative from your chapter 1, right? So from your section 3.3, you know that the derivative of x squared is 2x, the derivative of 3x is 3, and the derivative of negative 6 is 0. So there you have it, right? This is your first step towards implicit differentiation. Understanding that when you are taking the derivative of variables that do not match, right, your chain rule will have two different variables that don't match. And when you are taking the derivative of using the same variables, then the chain rule is dx over dx, which means it cancels, so we don't have to worry about the chain rule in that case. So let's take the derivative now of a circle. So what am I going to do here? Well, we're taking the derivative. I'm taking the derivative of x squared, which is 2x. We can put dx dx. So you read this, I took the derivative of x in respect to x. One more time, look at the screen. I took the derivative of x in respect to x. Because exactly that's what I did. I took the derivative of x squared, so I'm taking the derivative of x in respect to x because that's what I have, d over dx in front. Instruction is to take the derivative in respect to x. Plus, the derivative of y squared is 2y. It's just same old formulas. But now I took the derivative of y in respect to x. You see, so now you have dy dx there. Is equal to derivative of 9 is 0. So now, the dx over dx will cancel because it's just 1. And that's the reason why you never write it. If you match the variable you're taking the derivative of with the variable you're taking the derivative in respect to, and they're the same, well, you don't have to follow with the chain, only when they're different. So when I'm taking the derivative of y in respect to x, I have to follow with the dy dx chain. I will do, it will become second nature. I can also cancel these 2's, because dividing everywhere by 2, dividing 0 by 2 doesn't change anything. So what we are left with is x plus y dy dx equals 0. And now you see that you can solve for dy dx, and that will give you the derivative of this equation, right, which was the circle. So now you have y dy dx is equal to negative x, and finally dy dx is equal to negative x over y. And this is the derivative of the circle. But now you see that your derivative for the circle depends on both x and y. And that's new. Your old problems so far, when you find the derivative was strictly in terms of x. And then you plug in the numbers there to get the slope for the tangent line. Now you will have to plug in x and y coordinates of the slope of the point to find the slope for the tangent line. But you have the derivative. So now if I supply you with any point on the circumference of the circle, you will plug that point x for x and y for y and come up with the slope like this for the tangent line. What's the common sense slope? Well, let's say at 3, 0, right? At where the circle is the widest, the edge, you have 3, 0. So plug in 3, 0. That's negative 3 divided by 0. What's that slope? Negative 3 divided by 0. What is that? It's vertical, yes. So we call that the infinite slope. So the line is vertical. It's not going to be asymptote. It's just the slope is for the tangent line is vertical. It's infinity. How about a 0, 3? Well, 0, 3 is on top of the circle. It's horizontal. If you look at that for the tangent line, and what you have over here is going to be 0 over 3. Well, 0 over 3 is 0, and we know that the slope of the tangent line is 0. So let's no. Come on. So if you have a circle and you have your x and your y axes, you can have a horizontal tangent line with slope equals 0 at the point 0, 3. And you can also have a vertical tangent line where the slope is infinity because you had negative 3 divided by 0. So vertical, horizontal line, but anything in between. Give me any point on the circumference. I can draw the tangent line and I can use the formula below to calculate the slope of the tangent line. So that's our introduction. So now, what is there left? Just to practice a whole bunch of problems. Every time when the variables match, you are going to ignore the chain rule. Every time when variables do not match, you are going to follow with the chain. So let's take a look at some of these exercises. So how about the derivative in respect to x of sine y plus 3xy is equal to 9 plus square root of x. So I already told you the secret, right? Do it term by term. Every time you take the derivative of y, you have to follow with a chain. Every time you take the derivative of x, you can ignore it.
Yeah. Don't tell me it can't be done.
She did that. See, I dropped it once. You see what happened.
Exactly.
One time.
I dropped it 0 times, but still.
It's temper. I mean, even if you drop it, it won't. Temper glass will break.
Exactly. So, but you have to buy the case and the thing. Which is
My question is, which one is better, the S9 or S9 plus? S9 plus?
That's okay. It's nice and good. This part? No?
This is S9 plus.
Yeah.
Alright, correct.
So you can use it as a weapon. It's good.
All right, let's take a look at this. So this is introductory exercise. I let you work on it first because you'll see the pitfalls if and what to pay attention to. So I have 4 terms. So we'll start with the derivative of sine y. Derivative of sine y is cosine y dy dx. Very good. I took the derivative of y in respect to x, so I have to follow with that chain. Great. Next term. Would anyone like to? Wow. I mean, it's good because you are trying. That's commendable. Nice. How about now? If anyone would like to borrow my lenses? No? Alright, fine. What is that red dot over there? And what happens when we have product? Product rule. Very good. Boss. Boss. That's that. All right. So now that you know that the second term is product rule, go ahead, fix that. Probably the rest is just fine. All right, time is up. Copy the first, which is 3x, times derivative of the second. Derivative of y is 1 times dy dx because we took the derivative of y. Plus copy the second, which is y, times derivative of the first, which is derivative of 3x is 3. We could put dx dx, but we don't have to. Nah, put it. Equals to derivative of 9 is 0, plus 1 over 2 root x, again dx dx. So these dx dx, guys, they cancel. So anytime you take, you can put chain rule every single time you take the derivative. Simply the top says I took the derivative of, and then the bottom in respect to. That's what it is. So you took the derivative of x in respect to x, and that's why they cancel. Or you took the derivative of y in respect to x, they don't cancel. So that's what the chain rule is. Great. So now let's clean this up. We have cosine y dy dx plus 3x dy dx plus 3y is equal to 1 over 2 root x. You done? No. Because we are used to derivative equals everything else. So, what we have to do is factor out dy dx, move 3y to the other side. So there's some work to be done, right? Dy dx, factor out, you get cosine y plus 3x equals 1 over 2 root x minus 3y that you had to ship to the other side. And now I divide through by cosine y and cosine y plus 3x, and then we're good. Maybe. Cosine y plus 3x, cosine y plus 3x, and this is what I get. Dy dx is equal to 1 over 2 root x minus 3y cosine y plus 3x. And this would be done if it wasn't for the double fraction, right? So we just need to deal with that. Top and bottom times 2 root x. these derivatives are busy. So this is 1 minus 6y root x divided by 2 root x times cosine y plus 3x. Yay, there it is. Let's review the entire problem. The goal is to take the derivative of sine y plus 3xy equals 9 plus root x. And the way you do this is term-wise. You go to the first term, you take the derivative of sine y is cosine y, and then I took the derivative of y in respect to x, the chain rule, and it stays. Plus, and there's the product rule. I have a function 3x, that it's multiplying function y. So, 3x, so copy the first, the derivative of the second is, derivative of y is 1, and then I took derivative of y in respect to x, so chain rule stays, plus copy the second, which is y, derivative of the first, which is 3, and then dx. I took derivative of x, right? Because I took derivative of 3x. So I took derivative of x in respect to x. Plus derivative of 9 is 0, equals. Derivative of 9 is 0 plus the derivative of root x is 1 over 2 root x. Again, dx over dx. And then those guys cancel. The rest is algebra. Algebra so that you can fish out the derivative. It has to be, at the end, dy dx equals everything else. And you achieve that by factoring. That's the only way. You might run into derivatives that are going to have, 2, 3, 4 of these dy dx's. And your job is to put them all on the same side and put all the terms that do not have dy dx to the other side, like it was achieved over here. So these two terms remain on the left. This one gets shipped to the other side as minus 3y. And then when you factor out dy dx, you are left with cosine y plus 3x. You divide by that to remove it to get dy dx alone. And that's the first step. Now you go and you find your slopes and critical points and other things, right, that you might be interested in. Next example. Here the y squared minus 1 divided by x plus 3 is equal to 6 minus x squared plus y. And we want to take the derivative of this in respect to x. So what should we do here? Okay, once you're done crying, what should we do here? Anyone? I heard cosh rule and chain rule, and those are the two, yes. Is there anything else?
X squared minus 6.
What?
Can you expand the x squared minus 6?
No. What should we do? Cross multiply, guys. Simplify the thing. Why do you want to suffer through quotient rule if you can simply cross multiply and deal with cheap functions? Go on.
Sorry, would you like to do this? You can bring them in. Will it cross multiply? Or you can take cross multiply, then take the derivative of each separately.
So this problem looks really bad.
No, I'm creating it. Every time I write something, I want to make sure I'm getting it right the first time.
Yeah, good thing all the time was that we're getting it right off the bat.
Later, if anything is left. All right, let's take a look at this. So, yes, you can do quotient rule, but then you can also cross multiply and reduce the problem. So now we have d dx of e to the y squared minus 1 is equal to x plus 3 times 6 minus x squared plus y. Now I've seen some of you FOIL this, right, or expand this. You don't have to, it's just the product rule. And even if you expand, you are going to have x times y at one point, which is going to be product rule anyway. So you can just leave it like this and deal with the product rule. You will have one product rule either way. Great. The derivative of e to the x is e to the x. The derivative of e to the y is e to the y, dy dx. So the derivative of e to the y squared minus 1 is e to the y squared minus 1 times the derivative of the top, which is dy, and then follow with the chain of dy dx. So all of that stuff, right? The derivative of e to the y squared minus 1 is itself, times the derivative of the exponent, which is 2y, and then times dy dx, because we took the derivative of y in respect to x. Equal, and now we go copy the first, x plus 3, times the derivative of the second. Well, that's derivative of 6 is 0, derivative of negative x squared is negative 2x, the derivative of y is 1 times dy dx. So this is copy the first times derivative of the second, and now plus copy the second, which is 6 minus x squared plus y, times the derivative of the first, which is just 1. I can fit that over here. So now what do we have? On the left hand side I have 2y e to the y squared minus 1 dy dx. And on the right hand side I have to do some foiling now. So I have negative 2x squared plus x dy dx minus 6x and then plus 3 dy dx and then plus 6 minus x squared and plus y. All of the terms with dy dx go to the left and everything without stays on the right. So now we can deal with these three terms, factor out dy dx right away. We have 2y e to the y squared minus 1 and then minus x and minus 3. On the right hand side we have x squared, so that's a negative 3x squared minus 6x plus 6 plus y. And all I need to do is to divide by the parenthesis to get dy dx alone. So in the numerator 3x squared minus 6x plus 6 plus y, and in the denominator 2y e to the y squared minus 1 minus x minus 3. Spicy, huh? Let's take a look at more of this. I want to pick something from, yes. I have negative 2x squared and another negative x squared over here, which gives me negative 3. Fine? Right, so this and this together. So those two guys, actually I'm not sure if you see it because I'm using that. But this one and this one. So that's 3 of them to create this guy. So it's good to check these things because 2 and 3 are right next to it, so it's easy. I think you are ready to find the slope. No? All right. One more example. Give me a number 17 to 24. 17 through 24. You don't know numbers between 17 and 24? Okay, someone else then.
20.
Doesn't matter. That's why I'm asking to pick. 21 it is. I know. But see, the trick is, we all established by now that I'm a terrible person. So you just... All right, 6x cubed plus 7y cubed is equal to 13xy. So we're just looking for the derivative of this. Well, because you didn't have the book in front of you. Otherwise, I know you would pick something.
But you were all gung ho on the S4. I thought you were all gung ho on the S4.
Yeah, but well, no, you put the expanded memory in it, I put a new battery.
Yeah, like, I don't update it. No, it's still, like, when I update it, and then it,
It's contradiction confirmed. You can't use iPhone upgrades and say, because when they upgrade, it's not a bad
yeah, I know, that's why I don't update it.
40%.
Yeah,
You upgrade it to Samsung, you upgrade it to...
I won't even update. I still have a book, like 3 years ago. I just won't upgrade it, like,
They're saying that when you upgrade it shits the bed.
yeah, that's why I won't do it. Because I know it does. And then I need a new phone, and I already gave away my upgrade. I know, even like
Because I'm spoiled. That phone is 5 years old, still is, I still have it. 5 years old, and it works. Sluggish, extra 20 seconds load But if you put expanded memory and put it in the battery, box.
that's it?
And you just push the back like this. The back just slides off.
The phone?
Yes. You take the battery plus.
I don't think I have.
You do, it's garbage.
Oh, but you have to use a screwdriver to get in there. No, I
Special tool.
I won't do it. I just can't do it.
S4 is the best phone yet produced. If I put the S4 safe phone with just this processor on it,
Do you ever one that has like the screen that goes like the
yeah, it's wrong.
See, is it weird? Does it bother you though?
No,
Oh, you can use it.
you can't.
These ones aren't as bad as the
Oh, actually, that's kind of cool. It looks like it's like high definition or something. Like, what is that thing called? You put on your glasses. 3D. That's what it looks like.
Well, this one does virtual reality, there's augmented reality, there's...
Wait, that one with the headphones? What are you doing it?
He plays horror games.
Oh my
Like
god.
Haunted House ones.
No.
I don't have them on. You should bring one. Someone's tired of this stuff. I don't get involved. You gotta be able to stand your ground.
Yeah, really.
Don't look at me. Your stomach's coming to die. Yeah, I was just
You don't even need to put the glasses on? Oh. No, there's a shark coming.
This is shortcoming.
Right. You need to get. Do you text me watch? Like everything?
Like big sharks and tigers.
But you can like watch everything on that internet on it?
No.
Oh yeah, look at. Look at that one. Oh, you missed it.
Like 5,000.
Did you see it inside? I want one now. No, I can't. It's too complex.
No, it's just not idiot like your iPhone.
That's what I like about it.
So that was way too easy, I presume, since you guys have a lot of time to party. So we go with quick derivative on this one. 18x squared plus 21y squared dy dx equals to the product rule on the other side, 13x dy dx plus, copy the second y times 13, and then dx dx. Good. So now the terms with dy dx go on the left. And in parentheses, we have 21y squared minus 13x. On the right-hand side, we have 13y minus 18x squared for the total derivative of 13y minus 18x squared divided by 21y squared minus 13x. And that takes care of the problem. All right, the next one. Now, this is going to be trickier. Open parenthesis. X squared plus y squared minus 1. Everything raised to the third power minus x squared y cubed is equal to 0. Let's see the derivative of Okay. Let's take a look. We have, first of all, over here, chain rule, because everything is within the third power. And over here we have product rule. Very good. So we have to just make sure that every time when we take the derivative of y, we follow with dy dx. So we start with the chain rule. 3 goes in front. We copy the inside as is, right? Because that's the way the chain rule is done. Put a square up there. So that's the standard chain rule stuff, where you drop the exponent, copy the inside, and then times the derivative of the inside, which is 2x plus 2y dy dx, and then the derivative of 1 is nothing, so just leave it there. And then we have minus, and there is the product rule here. So copy the first times derivative of the second, which has dy dx, plus copy the second, and derivative of the first is 2x, equal to 0. Yeah, it fit. And I'm just going to walk away. Because now to FOIL this, you would get 9 terms on the first one, because you are squaring, right? 3 times 3 is 9 terms. So those 9 terms times these guys become 18 terms. And then you have these two. So this is a 20-term expression, which is the reason why I'm walking away from simplifying and making everything into dy dx. But then you might wonder, is it easy or hard to actually solve the tangent line problem on this one if I am not able to write the derivative equals to everything else? I mean, in the end, this is a curve which I graphed for you, so you can see it, right? So that's the curve. Yeah. You can see the formula right there in the upper left corner. So now this definitely has a tangent line, right? We can pick a value, let's say 1, 1, and there is a tangent line at 1, 1. Right, so say you're a surgeon, right, and you need the tangent line right there. Right, what do? Of course, you call me. So now, what do we do for the tangent line in this case? It clearly goes through 1, 1, so 1, 1 would be a good place to compute the tangent line with the setup that we currently have. Great. So let's just find tangent line at 1, 1 from the expression above. Well, the cool thing here is that we can plug in everything without actually solving for dy dx first. And it's a very powerful technique. So when I plug in 1, 1 for every x and every y, every dy dx becomes an m. And calculations simplify ridiculously. Look at this. Plug in 1, 1 everywhere. We have 3, 1 squared is 1, plus 1 squared is 1, minus 1, everything squared. On the other one is 2 plus 2m, right, because dy dx becomes m, minus 1 times 3 times 1, so that's 3m, plus 2 equals 0. So this is 1 plus 1 is 2, minus 1 is 1, squared is 1, so 3 times 2 plus 2m minus 3m plus 2 equal to 0. That's 6 plus 6m minus 3m plus 2 equal to 0. That's 3m plus 8 equal to 0, and m is equal to negative 8/3. We also have a point 1, 1, so y equal mx plus b. We have 1 equals to negative 8/3 times 1 plus b. So it is b equals 11/3. So what's the tangent line? It's y equals negative 8/3 x plus 11/3. Great. So negative 8/3. All right. Negative 8/3. So go 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 8/3. 1, 2, 3. Yeah. Not the greatest artist over there, but there it is. So yeah, that's that. Let's find another one. Problem 29 in a textbook. It's giving you the function, no, the function, it's not a function. It's giving you the curve cosine of x minus y plus sine y is equal to square root of 2, and they're asking you to find the line, the tangent line at pi over 2, pi over 4. This is an awesome exam question, so let's see.
Relax. I'm gonna go here to stay.
You don't have to the whole thing. You want
For serving. So, and you're serving all 7, so each 7. Yes. So you are going to take all of those things and divide them. How much do you tell them? With the math, exactly. If 9 is 200, how much more?
So fragile.
She's still
That's what we should have, all right?
I know, I have
Remember your
and he didn't have any with brain
right? So whatever is make no mistake. So whatever. I always like to I move in later. That's with my crew. Three of us go to one of those restaurants. Oh, they never make money. It doesn't matter what the price is. Yeah, that's fine.
I hear him all the time, like I'll walk over the wall and it's not here.
Yeah. You didn't know it. No.
Someone asked me.
Relevant to the world goes on. It's all this
I'm so great.
You think like, oh, he gets all the data, and you conflict makes she's just as crazy as him. This world is full of shit. What do you think will I put down? Walk in.
It's a billion for
You remembered. Yeah, some things they never forget, right? They stick. All right, let's take a look at this. So, seems that you guys are done. Would you like to do it on the board? No, okay, fine. Just checking. So the first part here is the cosine of x minus y. That's a chain rule, because the function x minus y is plugged in a cosine, so I have to take the derivative. Derivative cosine is? Negative sine. So negative sine x minus y. So times the derivative of the inside. The derivative of the inside is derivative of x is 1. The derivative of negative y is negative 1 dy dx. Plus the derivative of sine y is cosine y dy dx. And then the derivative of a square root of 2 is just 0. Now we are going to use the same trick as earlier in the previous problem. I am not going to bother solving this for dy dx. I am going to plug the numbers directly in here, replacing every dy dx with m. So I have negative sine x minus y, that's pi over 2 minus pi over 4, times 1 minus m, plus cosine of pi over 4 times m equals 0. Pi over 2 minus pi over 4 is pi over 4. Sine of pi over 4 is root 2 over 2, so we get negative root 2 over 2 times 1 minus m plus root 2 over 2 m, because cosine of pi over 4 is also root 2 over 2. That's equal to 0. Now we distribute. I get negative root 2 over 2 plus root 2 over 2m plus root 2 over 2m is equal to 0. And when I add these two, I get root 2m, because half plus half is 1, right? So, no coughing, root 2m is equal to root 2 over 2, from where clearly m is a half. So now I have m is a half, and I have the point pi over 2 pi over 4. Plug all of that into y equal mx plus b. So y is pi over 4, m is 1/2, x is pi over 2 plus b, so b is 0. Our tangent line is y equals 1/2 x. Wow. Look at that. After all the trig and sines and cosines and pi over 2s and pi over 4s and square root of 2s, we get 1/2 x as a tangent line. Awesome, right? 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 Right, good. Great. All right, so enough of the intro stuff. Let's take a look at fun stuff. All right? Here's the problem. Find the second derivative. In respect to x of what should we do over here? As what's better, 34, 35, 36?
36.
Of problem 36. Sine x plus x squared y equal to 10. Yes. So, this was supposed. So the derivative of cosine, right? Well, this is where.
This is my try. That's not what you. This is what.
Yeah, but the derivative of cosine, right? So the derivative of cosine is negative sine, and you copy the inside. And this is the derivative of x. The derivative of x is 1. The derivative of negative y is negative 1 dy dx. Because when you take the derivative of y, you have to follow the chain. Okay? Plus the derivative of sine is cosine y, right? And then dy dx because you were taking the derivative of y. And this is a number, so and then we replace every x with x, every y with y, every dy dx with m, and then just follow the algebra. So pi over 2 minus pi over 4 is pi over 4. Both sine of pi over 4 and cosine of pi over 4 are root 2 over 2. So yeah, so I can't write with this over here, but you need to write now sine pi over 4 and cosine pi over 4 are both root 2 over 2. Pi over 4
is equal to
square root of 2 over 2. And cosine is the same thing for pi over 4. And that's that jump. That is me.
okay.
That's good? Okay. This, so it's not this, right? Okay. So we have the sine x and we have a product rule, right? All right, good. Okay, let's take a look at this. What's the derivative of sine x? Cosine x, great. And what's the derivative of the second term? Two x dy dx, okay, plus? No. You copy first, and then dy dx plus y 2x, there we go, equals 0. So now we have our x squared dy dx is the term that stays on the left, and on the other side you have your negative 2xy minus cosine x. And then we have dy dx is equal to negative 2xy minus cosine x divided by x squared. Yay! That's the first derivative. But we want the second one. That means we have to take another derivative. And yes, it's a quotient rule. Nice. That's okay. So this is like the in-between step. And now we take another derivative of that in respect to x to get to the second derivative, because that's what we want. So now the derivative of this is going to be d squared y over dx squared, right? That's the derivative of the left hand side. And on the right hand side we have a standard, dare I say, quotient rule. So denominator is now x to the fourth, because x squared squared is x to the fourth. We put x squared here and then times the derivative of the top in parentheses. And yes, we have another product rule. So copy the first, derivative of the second is dy dx, plus copy the second, which is y, times negative 2. Derivative of cosine is negative sine, so we have plus sine x. And that's just the first part. Now we go minus for the quotient rule. And then we copy the top times the derivative of the bottom. So we have negative 2xy minus cosine x, and then times 2x as a chain rule. The derivative of the bottom. So now to simplify this, we can cancel one of the x's, so we have x cubed now in denominator. In the numerator, one of the x's canceled, the other one stays. And in parentheses, I have negative 2x dy dx minus 2y plus sine x. And then the minus distributes on the other one. And then times 2, because one of the x's canceled. Maybe I should indicate that by canceling like this. There we go. So now minus distributes, and 2 will distribute, so it becomes plus 4xy plus 2 cosine x. Now we multiply x to get negative 2x squared dy dx minus 2xy plus x sine x plus 4xy plus 2 cosine x, everything divided by x cubed. We can combine the like terms, and at the same time, you see the dy dx? Well, we know what dy dx is. It's right here. So plug that in. I know, right? So we have negative 2x squared. And now instead of dy dx, I have this whole thing up there. Now look at that as x squared. They're going to cancel. So negative 2xy minus cosine x plus 2xy plus x sine x plus 2 cosine x, everything divided by x cubed. So these guys now cancel, which is awesome. We have positive 4xy plus 2 cosine x plus 2xy plus x sine x plus 2 cosine x divided by x cubed. Well, a lot of common terms here. We have 4 plus 2 is 6xy plus 4 cosine x plus x sine x divided by x cubed. There it is. Welcome to the second derivative. I choose different color. Anyway. Simplifies nicely, right? After 20 minutes. Sounds good? All right. Well, that's the implicit differentiation. We are left with 3 sections, so let me just say bye over here. Bye.